Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 185. Day 185, we are in the process of solving word problems from day 101 to 200, and today is our 85th day. The problem for today is already on the blackboard. I'm going to read it to you. It says, what is the present age of a man who 3 years from now will be thrice as old as his son? 3 years from now, the guy is going to be thrice as old as his son. What does thrice mean? Thrice, not twice, thrice, T-H-R-I-C-E, thrice. It means 3 times as old. It doesn't mean 3 times as old, it just means 3 times, as opposed to twice. So 3 years from now, he will be 3 times as old as his son. We are told, we are asked to figure out the present age of the guy who, we are told, 3 years from now will happen to be 3 times as old as his son, thrice as old as his son. Just type, just like you're watching this video on algebra, I have also put together some videos to help you improve your vocabulary. Just type in Keshwani Prep dash vocab dash day 63, or you can just type in vocab dash day 63, and you will learn this word in depth along with some other words if you're interested in improving your vocabulary, particularly if you're planning in near future to sit for the SAT or the GRE or GMAT or even TOEFL. It is important that you have a decent vocabulary. We are further told, okay, let me read one more time. What is the present age of a man who 3 years from now will be thrice as old as his son, who is S years old today? This is S, not 8. This is letter S for son. This is not 8. My 8 is like that. So let's get going. Pause the video, solve it yourself, and then once you have the answer, you can compare your work against the work that we're going to do together. The very first thing we need to understand here is what is the known quantity and what is the unknown quantity. We are being asked here, what is the father's age? What is father's age? Current age. What is the present age of man, the father? In other words, everything else in here, the son's age that we're given here, that is given. Son is S years old today. This is a given quantity. This is given. This is a known quantity. Question is, what is the unknown here? The unknown here is the father's age. So let's pretend that father is F years old today. F years old. This is the unknown. We must understand the concept between known quantities and unknown quantities when we're doing an algebra problem, because there are no numbers here, or they are all variables. So if they are all variables, we have to understand what is given and what is being asked. What we are being told, that is the given, what we are being told, and what we are being asked. What we are being told are the known quantities. Son is S years old today. S is some number, obviously we do not know what it is, but we are told that he is S years old. The question is, how old is the father? How old is the old man? That's the unknown quantity. So here we go then. So we are told 3 years from now, 3 years from now, what's going to happen 3 years from now? Well, 3 years from now, we are told that father's age is going to be, we are told that father is going to be thrice as old as his son. Father says it's going to be 3 times as old as his son's age. When? When? Not today. 3 years from now. Well, we are assuming we're pretending, and we're going to solve for it. Whatever we pretend for f here, whatever variable that we use here, if we say let's pretend father is x years old, then we'll have to solve for x. If we pretend that father is f years old, then we have to solve for f. If we pretend that the father is alpha years old, then at the end we'll have to solve the equation for alpha. Whatever is the unknown. So father is f years old today. 3 years from now is going to be whatever his age is today plus 3 more, f plus 3. And this quantity has to equal 3 times son's age. Son we are told is s years old, so it's going to be s plus 3 years from now. That's it, we are done. All we have to do now is solve for f, and we are done. That's all there is. That's the unknown. F is the unknown. See? Where did it go? Let me show you in a red marker so you can see it. Our f here is the unknown. So we have to solve for f. That's it. Any other variable that appears here, they are all known quantities. Here it happens to be only one variable. S is the only variable that appears here. But even if we had 20 other variables in this equation, or even if we had 20,000 other variables in this equation, they would all be considered known quantity. Whatever variable that we are solving the equation for is the only variable that is treated as the unknown. That's why we solve for it, because we don't know what it is. Let's do it then. So 3 times s, and then 3 times 3 is 9, and here we have f plus 3. Let's get rid of this 3 from this side. Subtract 3 from both sides, and we'll get our f equals to 3s plus 6. Can we leave it like that? Well, I suppose you could if you wanted to, but a pure mathematician, your algebra teacher, would prefer that you present this in a more elegant form. How do we present this into a more elegant form? Well, that requires you understanding that when you have different factors, this is called a fact. This is rather different terms. This expression is 2 terms. This term and this terms. And when you have an expression made up of different terms, the convention in the algebra is that if they have any common factors, you must take out that common factor. That's why it's called common factors. You must take out that common factor outside and then represent the rest in the simplest form. Do you find anything common between 3s and 6, between these two quantities? Okay, pretend like this. Watch what happens. You see, s is some number, isn't it? S is some number. So here what we have is 3 times some number. Let's say here 3 times 7 plus 6. Well, 3 times 7 plus 6 is same as 3 times 7 plus 2 times 3. Do you find anything common in these two quantities? 3 is the common. 3 is common. We can take it out common. 3 comes outside. And what are we left here? We are left with 7. So 7 stays in there. And what are we left here? We are left with 2. There you go. And of course, if you were to open the parentheses, we will go back to where we were. 3 times 7, 3 times 7, and 3 times 2. That's your 6. That's exactly what we have to do here. So take out the 3 commons. I'm not going to write too low here because I don't know how low you can read. I'm going to continue here. Take out 3 common, and in the first term we are left with s. In the second one we are left with 2. Just like here, your s is the 7 and the 2 is right there. 2 comes from 2 times 3. That's it. So how old is father? The father is 3 times s plus 7. That's all. That's the answer. Are we done? Not quite. Not quite. We need to verify this answer. We want to make sure this answer is correct answer. And how do we go about verifying our answer in the algebra problem? By plugging in numbers in the problem, and thereby converting this algebra problem, this algebraic problem, into an arithmetic problem, and then redoing it and making sure that the answer that arithmetic gives us is the same answer that algebra gives us. So let's do that. We're gonna plug in numbers here, okay? Let's plug in. What do you want to plug in? How old? In other words, how old do you want son to be? Son, see, we're given here. Let's pretend that S are here. What do you want to plug in for S? Let's plug in 12 for X. So now the problem reads, I need the room, so I need to erase all of this stuff. So listen, now it's no longer an algebra problem. As soon as you plug in numbers for the variables, of course in this case, in this problem, it is not the case of variables, it's just one variable. S, that's it, only one variable is this problem has. S is the only variable. But as soon as you plug in numbers for variable or variables, it is no longer an algebra problem, it is an arithmetic problem. We just have to solve it. The question now reads, what is the current age, what is the present age of a man who 3 years from now will be 3 times as old as his son, who happens to be 12 years old today. So here's your son, and here's the dad, the old man, who is 12 years old today. So here's the now, and that's 12 years old. 3 years from now, this is getting too crowded, so I'm going to erase some more stuff. Actually, we can erase everything except our answer. And I'm going to rewrite the answer. The answer was F equals 3 times S plus 2. That was the answer. How old is the father? This is the answer. What is the present age of a father? Present of the father is this. F equals 3 times S plus 2. That's our answer. So, if we're going to pretend that the son is 12 years old, if you're going to plug in 12 for son, then 3 years from now, son who is 12 now should become 15. 3 years from now. And if son is 15 3 years from now, then the problem tells us that the old man is 3 times as old as son. So he must be 45. Well, if he's 45 3 years from now, then he must be 42. Let's do it one more time so we can follow the logic and follow the sequence. Where did this 12 come from? That's the first question. Where did this 12 come from? It fell from the sky. We just made it up. We plugged in a number for S. That's how we verify your answer. So this gives us 42 now. We're going to see what that gives us in a second, okay? So if son happens to be 12 years old, if we're pretending son is 12 years old, then 3 years from now, he should be 15. 3 years from now, he should be 15. Well, if he's 15 3 years from now, then at that time we are told, 3 years from now, we are told that his father is 3 times as old. 3 times 15 is 45. Well, if father is 45 years old 3 years from now, then he must be 42 today, which is what the question was. Now I'm going to put down these in boxes and put down sequences so you can follow it. So this is the first thing, we plug in number. Then 3 years from now, the son happens to be 15. If he's 15, then father must be 45. That's the third step. If the father is 45, then finally he must be 42 today. That's the sequence we're going in right here. You follow the arrow from here to here to here and finally to here. This answer that we arrived at before through algebra better give us the same answer as what we got here when S happens to be 12. When S happens to be 12, that bloody thing better come out to be 42. If it does not come out to be 42, then we will made a boo-boo. Then that answer is not right. Let's see what happens. 3 times S, which is 12, plus 2. 12 plus 2 is 14. And how much is 14 times 3? I don't know how much 14 times 3 is. I know 15 times 3 is 45. If 15 times 3 is 45, then 14 times 3 must be 3 less, because instead of 15 we have 14. Instead of 3 15s we have 3 14s, so it must be 3 less. Voila, it's 42. It is 42. It agrees. It agrees. What do you know? It is the correct answer. This is the correct answer. father is, question was how old is father? Father is 3 times s plus 2 if son is s years old, and if 3 years from now father happens to be 3 times as old as the boy. One more time. If boy is s years old today, and if 3 years from now the old man is going to be 3 times as old as the boy, then the old man must be 3 times s plus 2 today. That's all. We're done. I will see you tomorrow on day number 186. Alright? Bye now.